Hello everyone, my name is Volodymyr. I'm a PhD student at EPFL. In this talk, I'll present the analysis of Wikipedia trends in different languages. The main goal of this work is to analyze the differences and commonalities in readers' preferences across English, French, and Russian Wikipedia editions. To do that, we detect trends using Wikipedia viewership statistics and analyze collective interests of readers in those languages. Just to give you a quick intuition of what we're going to do, I'll show you this teaser. After the presentation, you'll have a chance to interact with this visualization by yourself. Here, you see Wikipedia articles represented as dots. Connection between them represent hyperlinks between articles. As you can see, these are pages related to the same topic, Miss America 2018. If you look at the timeline in the bottom of the slide, we can see that these articles are not very popular in the beginning of September, but on the 10th of September, when the show was broadcasted, a lot of people started actively exploring the cluster, and once the show is finished, their interest fades out. This way, we detect events that interest Wikipedia readers the most and use this approach to compare trends and language biases across editions. Now I'll tell you more about the technical side of the project. I will start with a dataset. We have analyzed 3 Wikipedia language editions, which is around 11 million pages connected with 700 million hyperlinks. All data is anonymized, and location and the click path that users followed are unknown. Second, let me introduce the method that we have used. First, we extracted subnetworks of trending Wikipedia articles. Then, we extracted keywords from Wikipedia summaries of those articles. After that, we have defined 9 high-level topics based on the keywords we have extracted. And finally, we have labeled all subnetworks with those topics. Now, I'll briefly cover every step in more detail. I'll start with the subnetwork extraction. We use the fact that Wikipedia has associative structure. As we saw in the visualization in the beginning of the presentation, if readers are interested in the topic Miss America 2018, they'll go and visit corresponding Wikipedia page. There, they will see links to the related concepts, and since readers are interested in this topic, they will want to click on those links and explore them in more detail. This is one of the main concepts of Wikipedia. If we formalize this concept, we can represent it as a walk around this kind of graph where nodes are Wikipedia pages and edges are hyperlinks between them. Different users will have different paths, but they will still visit the same pages related to this topic. Whenever they click on a page or a link in Wikipedia, their activity is recorded and stored as viewership statistics. To extract trending subnetworks, we used an algorithm that takes both network and viewership statistics and finds dynamic patterns in the network, so that if 2 pages have similar level of activity in a given time frame, it assumes that those pages are related and reinforces the connection between them. Once the subnetwork is built this way and extracted, we use Louvain community detection algorithm to detect clusters of trending pages. Once this is done, and we have extracted subnetworks, we need to define topics of the clusters of trending Wikipedia articles. We have used summaries of each article and extracted keywords, and based on these keywords, we have defined high-level topics of each cluster. Then we have labeled the subset of clusters, trained the classifier based on this data, and labeled the rest of the clusters in a semi-supervised fashion. As a result of all those steps, we get a labeled subnetwork of trending Wikipedia articles. Finally, let's compare the readers' preferences and see the results of our work. We analyzed 3 language editions of Wikipedia. Note that those are not related to countries or locations because we don't have location data. We have defined 9 most popular topics that interest Wikipedia readers and based our analysis on those topics. We have split sports and football in separate topics to avoid imbalanced classes when training our classifier. First, we have focused on global statistics and got quite interesting insights. We can see that English-speaking readers are mostly interested in sports. French-speaking audience prefers content about movies and music. And Russian-speaking readers are mostly focused on science, conflicts, politics, and religion. Note that topic religion is not at all interesting and trending among French-speaking readers during the period that we have studied. Now let's see what kind of topics are common and what kind of topics are different across the languages. We notice that interest in global pop culture and traumatic events like 9/11 and Stan Lee's death are common. They spark interest among readers of all Wikipedia language editions that we have studied. However, there are many events that appear only in one language. For example, local events like natural disasters, politics, and local events appear only in locally spoken languages. For example, Hurricane Michael appears only in English, Quebec elections only in French, and Soyuz spacecraft related to airspace events appear only in Russian Wikipedia. So why do the results look like that? We have a few possible explanations. First, it might be different media coverage. According to the study cited below, interests of 25 to 30% of Wikipedia readers are driven by news. We can also see the similar tendency in our study. Second, cultural differences between Western and Eastern cultures. As shown in the same study, readers from Western and Eastern cultures have different motivations when coming to Wikipedia. Most of the readers coming from Eastern culture are driven by so-called intrinsic learning motivation. This explains the domination of the topic science among Russian-speaking readers, which we see in our study as well. Finally, we can see that local events get more exposure in locally spoken languages. I would like to conclude saying that Wikipedia can tell us more than is written on its pages, and it's an interesting source of data that allows us to study cultural biases. In the future work, we would like to extend our study to more languages. As was suggested by one of the reviewers, we have tested Wikidata as an additional source of information. It simplifies topic detection pipeline, making it possible to easily extend the study to more languages. If you're interested in the results, visit the website of the project where you'll find the latest research results and datasets from our group. Also, on the website you'll find the interactive demo that I promised in the beginning. Thank you for listening, and now I'll be happy to answer your questions.